Okay, so let's talk about 5G. So here we're going to go over what 5G means, what are the implications of the 5G rollout, what the technology is all about, and what we can do to help protect ourselves from 5G. So, starting off, I want to talk a little bit about our Wi-Fi router because I often hear about 5G in people's Wi-Fi routers. So, I want to clear up what this means. Now, our Wi-Fi routers are often emitting two different signals. So, there's a 2.4 gigahertz signal that gets emitted by our Wi-Fi routers, and then there's another higher frequency signal which is in the 5 gigahertz range. So often when you're looking at connecting to a Wi-Fi signal, you're going to see two different signals for a Wi-Fi router. One of those signals might say 5G. This doesn't mean that it's 5G, it just means it's a signal in the 5 gigahertz range. That's not the same thing as the new 5G technology that's coming out and the 5G rollout. This is not the same thing as when you see 5G on your Wi-Fi router. Just as an interesting aside, 2.4 gigahertz that your Wi-Fi router pushes out is the same frequency that your microwave oven uses to cook food. So that's fun. All right, let's have a look at the evolution of a cell phone. Because really when we talk about 5G, we're talking about the 5th generation of technology. So let's go back to 1981 when 1G came out. And this was the big old Zach Morris cell phone, if you remember that. And these could only do cell phone calls. Big, huge batteries. They weren't very effective. But that was 1G. That's how it all started. It took almost 20 years for 2G technology in 1998 to come out. And this is when cell phones got a lot smaller. You could then start to do texts with 2G. This was the 2nd generation of technology. That lasted for a couple years before 3G quickly came out. And with 3G, we could do, again, phone calls and texts, just like 2G, but now we could do some basic internet browsing as well. So we had some data on there. And then 4G came out about 7 years later in 2008, and this is really where you could start to stream some video, have some good internet browsing speeds, and this is really, good enough for most people. You can get some pretty fast speeds with 4G, and it allowed for pretty easy internet browsing experiences. Cool, that's 4th generation technology. Now we are looking at 5G technology. And so this gives us much greater download speeds and allows different sort of 3D video and a lot of other crazy stuff to start being utilized with this 5th generation technology. So that's really what we're talking about with 5G. We're talking about the 5th generation of cellular technology. When we look at the 3G and 4G technology, just going to talk a little bit about frequency here, because when we're talking about the true 5G, we're talking about some much higher frequency ranges. And so we'll get into what that means. But what the technology that we've been using right now is 3G and 4G. This is what we're using in our cell phones, and the frequency ranges at which 3G and 4G operate are somewhere in the 450 megahertz to 2 gigahertz range. These are pulsed types of radiation that are put out by our cell towers, put out by our cell phones, and whenever you see a cell phone tower and when you're using your cell phone, the cell phones are constantly transmitting between the tower and your phone, sending beacon signals. Even if you're not calling or browsing or doing something on your phone, they're constantly in communication with the cell tower so that the cell tower always knows what cell phones are around and they can better hand off to another cell phone tower, and they always want to know your location so they can better distribute the traffic around cell towers and make sure you're connecting to the closest one. So they're always in communication, always sending out radio frequency. And again, let's keep in mind distance makes a huge difference with this. So when you're holding your cell phone, it's close to you. This is a radio frequency emitting device super close to you, so the strength is going to be much higher. Okay, that's 3G and 4G. So now when we're looking at the frequency range of 5G, let's have a look here. Because often what's happening with some of the 5G that's coming out is it's actually reusing the 3 and 4G ranges of frequencies, but it's modulating them differently. So it's changing how it's using those frequencies, but it's still using those lower frequencies. And there's a big reason for this, because the lower frequency ranges are actually able to travel further and penetrate through building materials easier. As you get higher up in the frequency range, those frequencies have a harder time penetrating through objects. And so this causes some issues as far as a widespread sort of distribution of 5G. That's not really how 5G is going to work. Not the same as how 4G works, where it can be just pulsed out continually from cell towers and you can connect to that whenever you want. 5G is completely different than that. So those frequencies all the way from 450 megahertz sort of thing, all the way up to 6 gigahertz. These are the sub 6 gigahertz range of frequencies. This is a lot of the frequencies that are being used for 4G right now, but they are being repurposed for 5G use. However, some of the true 5G frequencies, when you start getting into that 20 gigahertz plus range, then you start really getting into some much higher speeds, but you are faced with the problem of these frequency signals not being able to go very far, and they get blocked really easily by a lot of different building materials, even plants, even rain. There's a lot of issues with propagating those signals in a far distance and getting people to be able to connect to them. So this is important to sort of start to wrap our heads around as we're thinking about what the 5G rollout means for us. So because they have a harder time of, transmitting these higher frequency signals, which are in the works of being used, and they're already, auctioned off, and telecom companies own these different higher frequency ranges for use. But there's some issues with how we can actually use that on a large scale. So one of the ways that this technology is going to work is using beam forming technology. So right now our cell phones send something out sort of 360 pattern all the way, and a cell tower is sending out a signal all around. But with 5G, it's going to be more of a focused signal that comes right to your phone. So it's beam forming. You can see that this 5G antenna has a whole bunch of little antennas within it, and those all sort of beam in together to one area of your phone, and then this can send a signal directly to your phone in a much greater concentration of energy, which allows for a much greater speed, but also some difficulties in that signal is harder to get to. As you move, the beamform has to follow you. So this technology is still being evolved, but that's how it works. It's more of an on-demand sort of technology where your phone sends out a signal to sort of connect. It might do that through a 4G signal. Once you get a connection and you say, yep, okay, we're ready for a 5G connection, it'll beamform to your phone for that connection, transfer the data, and then it would stop when you are done that. It's on demand and it's beam formed. Now, these 5G antennas are going to pretty much sit idle until they are asked to send one of these signals towards a device. The 5G antennas will send out a reference signal, it's called, a very low power reference signal all around several times per minute to see if there's any devices which are looking to connect. That's quite a low power, nothing too much to worry about there, but it is quite a powerful beam whenever it is activated. So if you walk through that beam or something like that, you're going to be, getting that energy through you. So some more focused areas of radiation are going to be sort of going all over the place from these 5G antennas. Now, as I was mentioning, these are harder to penetrate walls. These higher frequency ranges, the plus 20 gigahertz, this is where we get into millimeter waves. So if you think back to what are EMFs, we talked about the fact that everything on the electromagnetic spectrum is essentially a wave, and these waves get smaller and smaller as you get higher up in frequency. And so when you're into the plus 20 gigahertz, these higher frequency ranges, which is where a lot of the true 5G will be, this has a hard time getting through structures. So what that means is the application for a lot of these beamforming technologies are going to be in big open areas where there's a line of sight from the transmitter and your phone. So things like stadiums, arenas, convention centers, downtown streets, metro stops, airports, campuses, etc. Those big populated areas are going to be where really those true higher frequency 5G signals are going to be used. Now, the beamforming aspect of this technology does allow it to get through walls a little bit easier. And as this technology evolves, perhaps that will get much more easier and they'll be able to beamform it much easier through structures. We'll have to see how it all sort of evolves and unfolds. But for now, if people want to bring that 5G signal into their home, there's separate units that can bring it into your structure and then pump it out from a device within your home. And that already exists. Some people utilize that now. That's what we really want to stay away from, is bringing any of these 5G signals into our home is one of the first things we can do to make sure we're not exposing ourselves to these higher frequencies. You really want to make sure you're not bringing any 5G enabled phones, any of these 5G enabled devices that are coming into your home that can then pump that signal out. That's certainly something we want to stay away from. Now, one of the concerning things about 5G is the small cell antennas that are part of the 5G infrastructure. So because the signal doesn't travel as far, because they need to beamform it to a location or to your phone from a much smaller distance, one of the ways that they are, sort of getting around this is putting small cell antennas on every light post, for example, in an area. And what this means is then those 5G enabled antennas will be every 50, 100 feet in a neighborhood, and they'll be able to beamform all over the place, let's say through an open window perhaps, or if you're outside connecting that signal, or it beamforms to somewhere on the outside of your house, which then brings it to that device that maybe you've bought to then pump that 5G out inside your house. That's sort of what it's going to look like. The real big problem with these small cell antennas is they're not only going to be beamforming 5G on an on-demand basis, but they're also going to be pumping out 3G and especially 4G signals all the time. So they're less power. They're about 1/10 the power of a cell phone tower, but they are drastically closer to your house. And with radio frequency radiation, and really EMFs in general, the closer you are to the source, it is much, much stronger the closer you get to the source of that radiation. So these small cell antennas that will be ready for 5G and can be activated for 5G whenever they are ready to, but they'll already be pumping out 3G and 4G constantly. So if you have some of these antennas close to your home, the exposure of the people inside your home with these small cell antennas close by could be greatly enhanced versus a cell tower a mile away. That's going to be a lot less, or a cell tower, half a mile away, versus a small cell antenna. Yeah, it's less power, but it's way closer to your house. So it could be resulting in a much higher level of exposure than you would have been before. Now, one of the reasons that this 5G technology is being implemented is so that the Internet of Things can be really, sort of fully realized. And what the Internet of Things is it describes physical objects that are embedded with sensors, processing ability, software, and other technologies that connect and exchange data with each other. So it's essentially sensors and transmitters in everything, so that everything can be tracked and traced to a crazy degree. So that every time you go and you buy something, it can be tracked that, oh, you bought that there and it went home and it got opened at this time and it got thrown out in this bin and it got put out to the trash at this time. And that sort of level of scrutiny can be put towards any object that has these devices enabled within them. And for all of that data to be sort of collected and sent back, you need a really big infrastructure of wireless all around us all the time with quite fast speeds. And that's where 5G comes in. 5G's purpose is not just to get us faster download speeds as it is sort of sold to the public. Really, you don't need much faster than 4G. Do you need to be able to download a movie in 3 seconds? Like, not really. But what really is necessary for a greater surveillance of the population is to implement sensors and everything, connect that to 5G, and then people can be really tracked and traced to a scary degree, even more so than we are now. So this is a big reason behind the 5G rollout. There's huge concerns with not only the exposure that's going to put us through with radio frequency radiation and all the health effects there, but then the huge issues with all of the privacy concerns, everything that's coming along with the 5G rollout as well. So sort of a two-pronged worrisome aspect there, the exposure and the privacy. These are the big things with 5G. Now, something else that's really frightening to me about the 5G rollout is the fact that there is a lot of 5G enabled satellites that are already up in low orbit around the Earth in our ionosphere, and a whole lot more planned to go up. But deployment has just begun. So there's a total, as of the filming of this, there's a total of 441,449 operating, approved, or proposed 5G satellites. And they're sending out radiation into our ionosphere, so into our atmosphere, and they're electrifying our environment to an even greater degree. And they're going to be beaming these signals down to different devices on the ground that can then capture it and send it out to other places. There are some satellites that can send directly to phones, but most of the technology isn't going directly to a phone. It's going to go to another sort of receiving area and then be sent out that way. But even when it's doing that, it's sending the signal through our atmosphere, which is electrifying it. And when you have that many creating this mesh network, all electrifying it, this is really frightening for what this might mean. And to get a better idea as to what are some of the implications of that and what has some of the electrification of our environment already done for us, I would highly recommend the book by Arthur Furstenberg called The Invisible Rainbow. This will go into all this in much greater detail, incredibly well referenced, easy to read, and really a masterful work in my opinion. So if you're looking to read on a little bit more about what the electrification of our environment does, I would really highly recommend The Invisible Rainbow. Okay, so can we feel these frequencies? Now, this is an interesting question. I want to show you some video here of a system called the Active Denial System. It's a non-lethal US military weapon. It's also called the heat ray, and it uses beamed 95 gigahertz rays to inflict pain. So have a look at what this can do.
Marines and several other DoD representatives had quite the heated demonstration at Quantico, Virginia from the Joint Non-Lethal Weapons Directorate.
This is a military area. Move away from the perimeter. I say again, this is a military area. Move away from the perimeter.
Their new active denial system boasts a reach far beyond any other non-lethal system.
Well, it's a versatile system, and it has a range of non-lethal capability that we can't even come close to with any of our fielded systems today that are in our military forces.
About 7 football fields to give it some perspective. It can deter individuals on a military perimeter all the way up to a riotous crowd, all without permanent harm.
It only penetrates 1/64 of an inch of your skin, goes very shallow into where your nerve receptors are, and there's no permanent injury caused by it. Very safe system. We built in some safety margins and training for the operators.
They even let any of the guests volunteer to test out its effectiveness and safety, including the Assistant Commandant of the Marine Corps, Sergeant Major of the Marine Corps, and Assistant Secretary of the Navy. Most described it as feeling like a hot oven or grill being opened up.
So keeping the 5G out, this is really what it's all about. Now, the best thing we can do is not bring any 5G in to start with. So not having a 5G enabled phone, not choosing any of this newer technology to bring into our homes that can then pump out these 5G signals. This is the first step. Now, we also need to be mindful about what are the devices installed around the vicinity of where we're living. So if you're in a house, this becomes easier to have a look around you to see if there's any of these small cell antennas installed on light posts or anything else around the vicinity of your house. This is going to be the first thing to do. They look like this. And so you want to be mindful of if there's any of these around you. This is the first thing you can do. And if you have some of these devices around you, well, they're going to be emitting usually 3 and 4G signals all the time. Now, it's these signals that we really want to make sure that we are blocking out. So there's different shielding options available. Anytime you're using shielding, I have to put a little disclaimer in front of it here because shielding can get very tricky. It requires some measurement before and after installation because often shielding can do the opposite effect. As it bounces and reflects the radio frequency around, it can have the opposite effect. So measurement's really important whenever we're installing any shielding. But there is things that we can paint on our walls. There's called Y-Shield paint. There's film that can go over your windows called Signal Protect. You can get Swiss Shield fabric, which also does a great job of blocking out RF. You can make curtains out of it. You can get canopies that go over your bed, which protect you when you're sleeping. So there's lots of options we can do to help protect, especially our bedroom environment, from these signals that are coming in. Now, if you're in a shared living space, like an apartment or a condo or something like this, well, measurement's really the only way to know what your neighbor's technology is giving you as far as exposure is concerned, because there could be a Wi-Fi router on the other side of the wall where you're sleeping, and you wouldn't know unless you're measuring to figure that out. Perhaps consider shielding if you see some of these, say, small cell antennas being installed around you, using someone who knows how to use these meters, finding a building biologist in your area, or someone else who has some experience in using these meters and hopefully experience in putting shielding in there too. So there's lots that we can do to help protect ourselves from 5G. So thanks so much for joining me. And in the next one, we'll get into a whole lot more EMF protection within the home.